Again, welcome to statistics class. In these lectures, we're going to discuss about confidence interval for population proportions. So our main objective is to learn how to find the point estimate for the population proportion, how to construct a confidence interval for a population proportion, also determine the minimum sample size required when estimating a population proportion. Also, we covered these topics already in our previous lectures, but we were concerned with the population mean. So for example, we know how to find a point estimate for the population mean, which is normally we find the mean of the sample that we collected, and that's a exact single value to approximate the population mean from the sample mean. Also, constructing a confidence interval for population mean, we learn how to find the margin of error. Then we add it and also subtract from the mean, the point estimate, and that will give us the margin of error and also the confidence interval. So confidence interval is normally the sample mean or population mean plus minus the margin of error. So let's start with the proportion. So here we start with the point estimate for population proportion. Now, what is a population proportion? Here we say the probability of success in a single try of a binomial experiment. So the keyword is again single try of a binomial experiment. So it's denoted by letter P. So next we can find the point estimate for P, which again the population proportion. And this will be the proportion of success in a sample. So we remember when we are looking for the point estimate, we always use the sample data, not the population. And whatever we get for the sample data, we approximate it or generalize it to the population. So that's the concept here, the proportion of success in a sample. And that will be the point estimate for P. Now, how do we find it? We donate it by P caret, which will be X over N. S will be our number of success in a sample. Then N, of course, our lowercase n is the sample size or number in a sample. So again, to find the point estimate for P, use the proportion, we said again is the number of success in sample, which is X, divided by the number in sample, which is the sample size. So we read the P caret as P hat. P hat. So the point estimate for population P or proportion, for population parameter, we used lowercase p. With sample statistic, we use P hat. So P hat represents the sample of the proportion and P lowercase p represent the population. So point estimate for Q, we remember when we cover the binomial distribution, if P is the success and Q is the failure, then Q equal to 1 minus P, the success. And the same thing we are doing here. So point estimate for Q, that's the proportion of failures, will be the Q hat equal to 1 minus P hat. We know in probability again, 100%, 1. So whatever we get for P hat, which is the probability of success, we subtract it from 1, then we get the Q hat, which is the probability of failure. Here we are using the term proportion of failure. So that's read as Q hat. So now let's see an example here. This is a point estimate for P. So here we say in a survey of 1219 US adults. So this is a survey. We have 1219 US adults. 354 said that their favorite sport to watch is football. Now our question is find a point estimate for the population proportion of US. adults who say their favorite sport to watch is football. So we know the sample, 1219, and also we know those who say their favorite sport to watch is football, which is 354. So the N will be the sample size, 1219, and our variable, random variable X will be our 354. So to find a point estimate for the population proportion, it will be the X divided by N. So 354 divided by 12N, which gives us roughly 0.290402, approximately 29.0%. Again, we said to find a point estimate for population proportion, it will be the random variable X divided by the sample size. So next we'll move to the confidence interval for P, again proportion. We know the C confidence interval for the population proportion P will be P caret or P hat plus E, and also P hat minus E. E will be again the same concept of margin of error. So E will give us ZC square root P hat times Q hat divided by N. So we can see a little bit slight formula difference here. So this is how we find the confidence interval. We need to find the E. In order to find the E, we should know the P hat, we should know the Q hat. When we know P hat, it's easy to find Q hat because we subtract the P hat from 1, we get the Q hat. And also we should know the sample size and also the critical value or the level of confidence. So here we say the probability that the confidence interval contains P is C. So in words, we say that identify the sample statistics N and X. This is constructing the confidence interval for P. So we write this mathematically by saying, let's find the point estimate, which will be the variable divided by the sample size. So after that, we need to verify that the sample distribution of P hat can be approximated by normal distribution, which will say that the P times P hat greater than or equal to 5, or Q times Q hat greater than or equal to 5. So from there, if this is true, then next we find the critical value ZC that corresponds to the given level of confidence interval. And we use the standard normal table. So after that, we can find the margin of error. That's what is our main goal. So when we get the margin of error, then we can find the end points for both left and right. So P hat minus E will be to the left-hand point. Then P hat plus E will give us to the right-hand point. So the interval P will be again P hat minus E greater or lesser than P hat plus E. So let's see an example here. Here we said a survey of 1219 US adults. 354 said their favorite sport to watch is football. Construct a 95% confidence interval for the proportion of adults in the United States who say their favorite sport to watch is football. So first, we look for our P hat. We can see that the P hat here, we did this previous example, is X divided by N. X is 354 divided by N, which is 1219, and you get 0.290402. So if I know the P hat, I can find the Q hat, which will be 1 minus P hat. So that gives us 0.709598. So if we know the P hat and the Q hat, then we are getting close to find the E. The first thing we do, we test if we can approximate it by normal distribution. So NP hat and NQ hat should give us a value that is at least greater than 5. So the first one gives us 354 because we have 1219 times the probability 354. The second also the same thing. We have 1219 times probability of failure, which is still greater than 5. So if these conditions are met, then we can find our E. So our E will be the ZC square root of P hat times Q hat divided by N. So since it's 95% 95% confidence interval based on the question, then ZC will be 1.96. Then we multiply the P carat with the Q carat divided by the N. So if we do this calculation finish, we will get 0.025. So after we know the E or the margin of error, now we can set our endpoint for both left and right. So P carat minus E will give me 0.29 minus 0.025. So the answer will be 0.265. Then the right hand point will be P carat plus E, which will be 0.29 plus 0.025. So final answer will be 0.315. So now we're going to get our confidence interval for P constructed. So we saw the point estimate was 0.29. Then we saw that 0.265, then 0.315, which is in the previous slide. So we can see the values. So we know the answer now. So next is how to find a sample size. So given a C confidence level and a margin of error E, the minimum sample size, lowercase n, needed to estimate P is given as follows. So we have the P hat times Q hat, parenthesis ZC divided by E all square. So this formula will assume you have an estimate for the P carat and also the Q carat. If not, then use P carat as 0.5 and also Q carat or hat as 0.5 also. So this example given here, they say you are running a political campaign and you wish to estimate with 95 confidence. So we have the confidence level, the proportion of the registered voters who will vote for your candidate. Also, your estimate must be accurate within 3% of the true population. Now the question says we should find the minimum sample size needed if one, the normal primary, no primary estimate is available. Because you do not have preliminary estimate, we can say P character is 0.5 and Q character will be 0.5. So here we have the C 95%, which is the same as 0.95. Now, when your C is 0.95, ZC will be 1.96. Then we have our E, which is given to be 0.03. So if that's the case, we can find the N. N will be P carat Q carat CZ over E all square. Then we can run up to the nearest whole number. Again, this is a sample size, so it have to be a whole number. So roughly we get 1068 voters. So another example for the sample size. Here you are running a political campaign and wish to estimate with 95% confidence the proportion of registered voters who will vote for your candidate. And also your estimate must be accurate within 3% of the true population. Now the question says find the minimum sample size needed if one, the preliminary estimation gives 0.31. So use the preliminary estimate P hat is 0.31. So Q hat will be 1 minus P hat, which is 1 minus 0.31. So we know the C value 0.95, SC is 95% confidence interval will give me 1.96. E also is 0.03. So with these three values, first we can find the sample size, P carat, Q carat, CZ over E all square. So that gives us 913.02. So we run it up to a whole number. So our answer will be 913. So this will be the conclusion of our lectures. In these lectures, we discuss about how to find a point estimate for population proportion. Also how to construct a confidence interval for a population proportion. So again, wish everybody the best. And if you have a question, again, feel free to send an email or you can reach me on my cell phone. Thank you.